So today we'll discuss comparing two means using SPSS. Basically, we'll discuss t-test. Okay.
Hmm.
But before discussing t-test or before discussing how to calculate t-test in SPSS, we have to know certain concept. Okay.
Hmm.
So we'll start now. The topic that I'm going to discuss in today's class are first I will discuss error bar and confidence interval. Both of them are related to t-test. Okay. And obviously then I will discuss t-test and two types of t-test, independent and dependent. Okay. Now,
Okay.
just tell me what is your idea about experimental research? Okay. You tell me, then I will show you the slide. Okay.
Okay, so as far as I know, it would be like there would be two variables involved. One would be independent and one would be dependent.
Okay.
And it will be like the experimenter will be making changes to the independent variable to see what the effect is on the dependent variable.
Yes, yes, you are absolutely right.
Okay.
The same thing I have written here.
Hmm.
So I will use the word manipulate than change because it is
Yes,
much more scientific. Otherwise,
appropriate.
it is much more appropriate. Otherwise, it is fine. So basically, in experimental research, we manipulate IV and we see the effect on DV. Okay, like I have given one example. Like if I want to see the effect of reinforcement on learning, so I can manipulate the IV, that is reinforcement, and then I can take two levels, positive and negative reinforcement, and I can see its effect on DV, that is learning. Okay, so in experimental research, if there is two groups or two means, okay, then we have to check whether the mean they differ from each other and whether they have significant difference. Okay,
Hmm.
significant difference means a mean can vary because of chance factor or because of the manipulation of independent variable. Okay, so if our objective is to see whether the means of two groups they are different because of the IV or because of chance factor. Okay, if it is because of IV, then only we can conclude that okay, IV has some effect. But if it is due to chance factor, then we cannot say that okay, it is a effect of IV. Okay, so it is the objective of statistical analysis when we are doing experimental research. Okay, so if there are two groups, then we will use t-test. Now, hope you have idea about between group design and within group design or repeated measure design.
No, this I don't have
Okay,
any information.
between group or between subject or independent design basically means when we take two separate group, okay, and we see the difference between that group. So suppose I want to see different between suppose um, male and female. Okay, so there are different group and different participants are there, and we'll see the effect of male and female on anything, maybe on anxiety, okay, or stress level, anything. Okay, so that is between group design. So for between group design, we will calculate independent t-test. Okay, is it clear?
Can you say that again?
Between group means we have two different group of individual. They are completely different from each other,
Hmm.
like male or female, maybe. Or maybe I have taken two group. One is one group who is suppose I want to see the uh, effect of teaching method on individuals, okay, or on children. And I have taken two group. One group they like I am giving I am using online mode to teach them, and I have taken another group. Group A I am using for group A I am using online teaching, and for group B I am using offline teaching. Now I want to see whether there is any difference between these two groups. So that is between group design.
Hmm.
Okay.
Hmm.
And within group means when I am using same subject again. Or within group is also called repeated measure. Generally the pre-post test, these are within group design. Means I want to see effect of some intervention. Okay. Suppose I want to see the effect of CBT on subjective well-being of participant. Just
Oh.
hypothetically think. So what I'm doing, I'm using same subject, and first I'm taking a pre-test measure on subjective well-being, then I'm giving the intervention, and again I'm taking a post-test measure. So I'm using the same subject again. So that is called repeated measure design. Is
Huh.
it clear? Okay.
Yes.
So when we are using repeated measure design or within subject, then we'll do dependent t-test. So in this lecture, I will discuss
Can
both
you repeat
uh,
that? Where do we use the dependent t-test?
in within subject design. I will show you. I
Okay.
will show you. Okay,
Okay.
and
Okay.
in between group subject or between group design, we'll use independent t-test. Okay, so just remember this two type of method of data collection. So because in next class when we discuss ANOVA or repeated measure ANOVA, again we need this concept. Is it clear, Anna?
Yes.
Okay. So now, like I discussed, that there are two type of variation in data. So two group may differ because of systematic variation or because of unsystematic variation. Now, what is systematic variation? Systematic variation means variation due to manipulation of IV. Means when I am manipulating IV, that it is a reason what cause variation in the data. That is called systematic variation. Okay,
Mm.
and unsystematic means variation due to some random factor. So suppose I want to see the effect of teaching method on children learning. Okay, and I have two group. One group I'm using only lecture method, and for group B I'm using lecture and audio visual presentation. Okay, so I want to see whether there is any effect of teaching method on learning. So here I am manipulating the IV, and if there is any change, then any difference between group A and group B, that then I will say that this is a systematic variation because this change happened due to the manipulation of IV. Is it clear?
Yes.
Okay. But apart from IV, other factors are there which can be the reason which cause differences, like maybe the intelligence of the participant, or maybe the mental condition at that moment of the participants. Okay, so this factor are called unsystematic variation. Now in statistical analysis, our objective is to find how much variation there is on DV due to the systematic part and due to the unsystematic part. So we want to find the systematic variation. It is our objective, but we have to know if there is differences because of unsystematic thing. Okay, and that is the reason why we see the significant difference. Is it
Oh,
clear?
yes.
Okay. So there are certain method by which we can control this unsystematic variation, like randomization. We select subject randomly. Okay. This is one very important method generally researchers use to control the unsystematic variation. Okay, we randomly select subject. Random selection means we have the every individual in the population have equal chance of being selected. So you have any idea about population and sample?
Yeah, like
Okay.
population would be like the entire thing, and sample would be representation of that population.
Exactly. So just let me show one diagram. Then, okay. So I will use this to explain standard error, but I'm now using this to explain sample and population. So this is a sample, and these are the sorry, this is a population, and these
Population.
are the sample. Okay.
Hmm.
So now, right. So sample, how we draw sample randomly. If we use randomization, we select sample randomly, then it may happen that it can control the unsystematic variation. Okay, this is one method. So suppose I want to know the effect of teaching method on children, maybe children of grade 5. Okay, so it is not possible for me to select all the students from a particular city. So what I will do, I will think that okay, I will select only this student, and I decided randomly. Okay, maybe I will select I make a random table, and on the basis of that table I select some individual, and that individual will form a sample. Okay, so randomization is a method which we can use to control unsystematic variation. Okay, clear?
Yes.
Okay, another thing, when we are using repeated measure design to thing which can cause unsystematic variation, that is called practice effect and fatigue effect. Okay, any idea what is practice effect and what is fatigue effect?
No, I don't.
Okay, so it may happen. So in within group design, what we are doing, we are giving same test to same group before and after Hutton intervention. Okay, so suppose I want to see the effect of particular training on on um, on memory. Okay, so what I am doing, first I am administering a memory test, then after that I am giving a training or intervention for certain period of time, and after the intervention again I am giving the memory test. Okay, I am administering the memory test. Now practice effect means once a subject they are exposed to the test, it may happen that due to practice, they are in the post test measure there is an improvement because of practice. Already they are exposed to the particular test, and because of practice they have improved, not because of the intervention. Okay, so how can I say that the difference between pre-test and post-test is due to intervention or due to the practice effect? It is difficult for us to say, right? Am I
Yes.
clear? Okay,
Yes.
so this is called practice effect. Opposite thing also can happen, like once the participant they are exposed to a certain test, and after that we are giving intervention, again we are administering the same test. It may happen they are very tired, and mental fatigue or physical fatigue are there, and because of that in the post test their score is low compared to the pre test, or their performance is poor. So here also we cannot say that we cannot decide whether the differences in pre-test and post-test is due to the intervention or due to the fatigue effect. Okay, so we these are called practice and fatigue effect. Is it clear?
Yes.
Okay, so in that situation what we can do, we can counterbalance. This is another method. In counterbalancing, what we do, suppose I have 5 participants. Okay, so I can do one thing, like suppose I want to see the effect of time on memorization of elderly group. Okay,
Mm.
so what I will do, I will collect memory data on morning and afternoon session. Okay, so my suppose there are 20 participants in my group. Huh. Okay. So what I will do, like for 10 participant, first I will take in the first I will take data in the morning session, and then afternoon session. And for rest 10 participant, what I will do, I will take data of afternoon session first and morning session, morning session later. Okay, so that
Oh,
is a method of counterbalancing. So it may happen that so if there is any unsystematic variation, that in this way we can control it. Okay, but
mm.
obviously it is not possible for us to completely control the unsystematic variation. There will be some unsystematic variation, but we will try to minimize it so that it will not affect our data or our analysis. Okay, and I will show you how we can use statistical method to control the variation. So is it clear?
Yes.
Any question?
No, not as of now.
Okay. Now, in this today's class, there will be many theoretical concept. Okay, but I have to explain them. Otherwise, you will not understand t-test.
Okay.
Okay. So if any problem if you have any problem, you can question me. Okay. Now, like we already discussed that whenever we are doing any kind of statistics, first we have to draw a graph. Okay, because graph they represent data, and it's very it is good to use graph to explain our data. So in t-test we use a bar chart. This is called error bar. I didn't discuss error bar when I was discussing graph. Today I will discuss error bar. Okay.
Hmm.
First, we have to know the theoretical background. What is error bar? Error bar I have written here. It is a graph which show where the true value of mean lies. Okay. Now, when just let me explain this thing, then standard error and everything, then you will understand. So suppose this is my population and this is my sample. Okay. So from a particular population, I can draw many sample, right? So this sample they have their like suppose this is the sample. Now it is expected that if I am deriving many sample, all the samples they will have same mean, but in reality it is not. The mean will differ. Am I clear?
Yes.
Now if there are, suppose there are 1 2 3 4 5 6 7 and 9 samples are here. Okay, from the same population. Now they have 9 different mean. Now we can calculate one mean of the mean, which is called, is mean of the all mean. Okay. Is it clear? Hello?
Yes.
Okay. So mean of the all mean, fine. And if we calculate mean of the all mean, then we'll get some standard deviation, because it is not like that every they are equal, exactly equal. Okay, we'll get some standard deviation. Okay.
Hmm.
So this standard deviation is called standard error. Is it clear?
Mm,
Not clear.
not completely clear.
Yes,
Like,
yes, yes, yes.
mm.
Okay, I'm telling you. Just a minute. Just let me.
Okay, so I remember this one concept they told us in class that with each research there will be a margin
Hmm.
of where it's not exactly according to you. Like if there's like a 5% difference or something, then it's still a valid research. If it goes
Yes, yes, yes.
beyond that, it's the same thing, right?
Yes, yes, yes. That I'm coming, confident interval. That I'm coming, but first you have to understand standard error. So
Okay.
just let me show you. Suppose from this sample, from this population, we can draw 9 sample. Okay.
Hmm.
Now, as I'm drawing the sample from the same population. It is expected that all the samples they will have same mean, exactly same mean,
Hmm.
theoretically. But practically, it's not like that. The mean they differ from each other. Okay. But if it differ too much, then that will be questionable, and then we have to think what we will do. But if the difference is not so much, then it's fine. Okay.
Okay.
So suppose these are the mean of the different sample. 3 plus, sorry, 3 plus 3 plus 2 plus 1 plus 4 plus 7, like this. Okay. So these are the mean of different sample. Is it visible?
Yes.
Let me increase
Huh.
the font size. Just think hypothetically. Okay. So we can have a mean of this mean. Okay. So 17 is the total, and 17 by 5 will get a mean. Okay. 3 point something. That will be the mean of the mean. Right.
Hmm.
3 point something. That will maybe 3.5. That is the mean of the mean. Okay. And then we'll get a SD for each mean. There will be a standard deviation also. Right. SD means the spread of the mean around this thing. That is called standard error. Is it clear now?
Yes.
Okay. So mean of the mean and SD of the sample mean, that is called standard error.
And
Okay. Now when I'm using error bar, that error bar will show us like the limit within which the true mean will lie, means the population mean will lie. Okay. So like just let me show you the error bar, then I can explain you. Maybe this variable A and variable B. Now how I'm going to draw the error bar? So go to graph, legacy dialog, and here is the option error bar. Here in t-test we will only use sample sorry, simple for the cluster. And for this is the within group design we have to use summary of separate case variables, and between group I will explain you this a bit later. Okay, just let me explain the error bar first. So now uh, so this is the error bar. Okay. Okay. So this interval, the upper and lower limit, it indicating that within this limit the population mean will fall. Okay. So we have drawn a sample. Okay. And we know that if we draw other sample from the same population, it's not like that the mean will be the exact same. They will be similar but not exactly same. So we need to know the population mean. And error bar is the bar which shows us the population, the range of the population mean. So we know that the population from where we have drawn the sample, the population mean will be in between these two range. Okay, and 95, when we take 95% of the confidence interval, by default in spaces it is set. Okay, and everywhere you can see it is there. Just like I'm showing you in the error bar, you can see it is already there. Just a minute. Legacy error bar. You can see we can change it, but it is always better if we take 95% interval level, confident interval. Okay, so by
Hmm.
default it is there, you don't have to do anything. Okay, so 95% confident interval means in 95% of the cases out of 100, 95% of the cases, the population mean will fall within this range. Okay, and this range, you will find this range once we have calculate the t-test, you will find the range there in the table. So is it clear what is error bar and why we need this?
Yes.
Why we need this, that I will explain you. But what is error bar and what is standard error, it is clear.
Yes.
Okay. So, um, so 95% of the confident interval means we are 95% confident that this interval contains the population. Means
Population.
in 95% of the cases out of 100, we can say that the population mean will be there within that range. And in 5% of the cases, there is a chance that mean will not be there, but that 5% we can tolerate. Right. Now in t-test, our assumption is that we have taken the sample from the same population. Okay, so now if that and if there is difference between the mean of the two sample, now we can say that the mean is different because of the manipulation of IV, not because that we have taken the sample from the different population. Is it clear why we need this thing?
Can you just repeat the last line you just said?
Okay, so just think why we are doing t-test. We are doing t-test to see. So two samples are there, and we have taken the sample from the same population. Okay, so
Hmm.
as we have taken the sample from the same population, so they will have similar mean, maybe
Yes.
not exactly same, but similar
Similar.
means the
Hmm.
means are not different from each other significantly. Okay, now if the mean differs significantly, then we can say that okay, this different significant difference is possible because of the manipulation of IV. So just let me give you one example. Suppose group A and group B, we have taken both sample from the same population, right?
Hmm.
And so they will have similar mean, or they will have similar, and we want to see the effect of their learning ability, and it is assumed that they will have similar learning ability because they are from the same population. Okay, now when I am giving them different IV or different levels of IV or different method of teaching, and I see that they have significant mean difference, then I can conclude that this mean difference is because of the manipulation IV, not because they are from different population. Is it clear?
Yes.
Okay, that is the reason why we need to know the error bar, we need to know the confidence interval, all this concept we need to know. Standard error. Okay, now so the size of the confidence interval depends on standard error. Okay, if standard error like just a minute, I have mentioned somewhere here. Um, Many things are whatever I have explained, this is written in this slide, so I'm not reading the slide. Okay, so just one thing I want to say. So standard error, if the standard error is if the standard error is large, then we can say that the sample mean they deviate from each other a lot, right?
Hmm.
Okay, you can see it is written, a large standard error tell us the sample means can deviate quite a lot from the population mean. So but if the standard error is small, then we can say they do not differ from each other. So they are taken from the same population and they do not differ from each other. So it is expected that our standard error is always less. Okay, is it clear? if,
Yes.
if we have taken the sample from the same population, then it is expected that standard error is less.
Less. Hmm.
Okay, it is clear now.
Yes.
Okay, any question? Okay,
So,
now
I just had
yes.
one question. So,
Hmm.
if like How is standard error and that confidence interval different?
They're not exactly different. They are confident interval is the interval where the it is an interval, okay, within which we know the population mean is there, okay,
Yeah.
and we can take different level of confident interval, but it is accepted that we use 95% of the confident interval. Means in 95% of the cases we know that within that interval population mean is there, okay. And standard error is the standard deviation, means how the mean of the sample they deviate from the grand mean, means total mean. Am I clear?
Okay, so
Hmm.
if I have to like simplify it, the confidence interval is more like a numerical thing, like the numerical that is attached to the concept, and standard error would be more towards the standard deviation side.
Yes, both of them are numerical. We can express them. A confident interval is a range.
Okay.
Once I will discuss the tables now, it will be clear to you.
Okay.
Confident interval is basically a range of data. Means upper interval, lower interval, and we know that within that interval, our mean population mean is there. Okay, and standard error is simply the standard deviation of the sample mean. Means like I say na, in our sample you can see the different mean 3, 2, 4,
Hmm.
3, 1. Okay, and when you calculate mean of this mean you will get one mean there. Maybe the mean is 3.5. Now all the mean they differ from 3.5, maybe maybe 0.5, 1.5, or 2.5, like this, okay. So that in the, if we consider this spread of the mean around the population mean, then that is the standard error. Am I clear?
Yes.
Okay. Now, why we need error bar, or what error bar will tell us from about the data when we are doing t-test. Okay. So, like you can say if the confidence intervals overlap, means here in this case you can see these two, there are some overlapping,
Huh.
right? And it means that the mean came from the same population. Okay, so in after like in analysis, it is expected that in error bar you can see this written they do not overlap. Okay, so sorry. If the bar they do not overlap, then we can say there is significant difference between the groups. Okay, so
Hmm.
here if the bar they do not overlap, then we can say the group differs significantly from each other. Okay, so basically, like I say, the graphs always help us to explain the data, and they give additional support to the data. And it is always good if you use bars, especially when you are giving presentation or you are reviewing some research. Okay, so you will calculate. Now, once you calculate your t test or ANOVA, you will get the result. But still, you have to use graph to explain to support your findings. So here you can see that if they overlap, it means they if the bar they do not overlap, then we can say they have significant difference. But if they overlap, then from this graph we can say that okay, maybe the data they are not significantly different. Okay,
Okay.
is it clear? So that is the reason why we need to draw error bar. Okay,
Hmm.
now there are two type of error bar when we are using repeated measure design and when we are using within sorry between group design. Okay, first I will explain between group design, because in repeated measure design lot of corrections we have to do. So I will explain that a bit later. First, I will explain error graph for between subject design. Okay. So you can see just simply for between subject design, you have to go to graph, legacy dialog, error bar, and two options are there. You can see here. I have you have shown paste the picture here. So summaries for group of cases, summaries for separate variable. For between subject design, you have to click on summaries for the group of cases. Okay, now why that I will tell you. Just let me show you. Okay, between in okay, one thing you have to remember, when you are using t-test you have to enter data separately. Means the process of data entering is different in independent t-test and dependent t-test. Okay, is it
Okay.
clear?
Okay.
So
Yeah.
in independent t-test or separate sorry different between group design means when we are using two different group, right?
Hmm.
So just let me show you. Then clear. So this is now I will show you between group data. Mhm. Okay. So this is a between in this way we have to enter. Okay. So in between group in case of between group design we have to enter variable in one column and the coding in another column. Okay. Let me- And then we have to define it. Go to variable view. This is your variable. Maybe anxiety is your variable. Okay. Or let's make it stress, not anxiety. Stress level. Okay. And this is a grouping variable. And maybe your values you have to add here. 0 means simply male, and 1 means female.
Hmm.
So in between group design, you have to uh, you have to enter the variable in one column and the the group in another column. So these are the 0 level means the male and 1 means female in this way. Clear?
Hmm.
This is very important and please remember this one. Okay, how you have to enter data in case of between group design. Okay, then what if you want to draw error graph here, you have to go to graph, legacy dialog, then error bar. Okay, we'll use simple because we have only two set of data, and here we have two options. In case of independent test, we'll use summaries for the group of cases. I have mentioned here summaries for the group of cases. Okay, and then click define, then send your variables here, and the variable will be in the variable and categorical access means the group. Okay, and don't do anything. You can see the full confidence interval is by default 95%, so you don't have to do anything here. You don't have to change, and then click OK. Then you will get.
Hmm.
Okay. And in case of this data, we can say that they are not overlapping, so maybe they
Hmm.
have significant difference. Okay, is it clear?
Yes.
Okay, so please remember this thing. Entering data for between group design or independently test, always you have to click this one, summaries for the group of cases. Okay, clear?
Yes.
Then next is for within group you can see many slides are here. So means in within group we have to do certain adjustment and correction and everything, so I will explain them. So in repeated measure design we don't have to enter data like this way. Sorry, in this way in between group design we'll enter data into different columns. Okay, so just let me show you one data. Okay, input data. Mm, okay, with this one, just simply assume that these are pre-post data. Okay. Mm, you don't need any coding here because there is no grouping group. It is already like groups are there in different columns, so we don't need to code anything. So for
Hmm.
this one, you have to go to graph, legacy dialog, then error bar, and we'll use simple. And you have to change these summaries for the separate variables. Okay,
Hmm.
and then define. Then you send your variables here in this thing. Sorry. You can also drag your variable like this. Okay,
Hmm.
and you don't have to change anything here. Just leave everything the way it is, and then click OK. I'll get pre-post, they are overlapping. Okay, is it clear? So this is very
Yes.
important thing you have to remember. Okay, if it is clear, then I will move to the next one. It is clear now.
Yes, it is.
Okay. Now the repeated measure design means in case of error bar or in case of repeated measure design, it is not so much simple. Okay, there are certain things we have to do, certain correction we have to do. So repeated measure design, like I say, that same group of individuals we are using in different situation, right? Um, but in repeated measure design, when I am taking the subjects, the participant they differ from each other, right? It's not like the participant they're exactly same. Like maybe I have taken 10 individuals. The 10 individuals they will differ from each other, right? They're not. We
Hmm.
cannot say that they're exactly same. Now we have to design our research, design our experiment in such a way that we can control these individual differences, right? Like there is a chance that the participant they may differ because of their intelligence level, then what we will do, will you administer a IQ test and we'll take participant who have similar IQ. Or if the participant they differ because of their gender, then what we can do, we can take sample only from the one gender. Okay. Or the individuals they differ because of geographic location, we can take data from only one geographic location. Like in this way we can control, but still we cannot say that the individual difference is completely like we have overcome the difference, right? So even if we have controlled them by using different method through our data, it's still people they differ from each other. We all different from each other, right? So
Yes.
in that case it may happen that okay, we are saying that we are using same subject, it is a repeated measure design, but people they differ from each other. So some it can be a between, it can become like the error graph can be like between group design, right? So
Hmm.
we need to do some adjustment statistically, which we can do, right? So what
Okay.
we have to do, there are certain steps. Please don't get panic by seeing all this thing. It's not so much difficult. Okay.
Okay.
Just you have to remember, and whenever you are using it, please go through my slides and you can do it easily. Okay. So
Okay.
what we have to do, like we did transformation, if you remember, for correcting the outliers and everything.
Yeah, I have it in my notes, but I don't have my notes right
Okay,
now.
you don't have to panic. I will show you again. We'll use the same thing. Okay, so we have to do a correction. So
Hmm.
what how we have to do? First, we have to go to transform. Every steps I have mentioned here, every step, and I have given the picture, so it will be easy for you to remember when even if I'm not taking your class. Okay, so
Hmm.
first we have to go to transform and then compute. Okay, so
Hmm.
when you will go to compute, you will have this dialog box open. Okay, so what you have to do, first you name your target variable. First we will have a mean. Sorry, first we have to calculate mean for each participant. Okay, so first in the first target variable, write mean. Okay,
Hmm.
and then go to all function group, go to all, and here you have to find mean.
Hmm.
You find mean here. Just yeah, there it is, mean. You can send it here. Okay, you can see two marks are here. You have to send two variables here in this question mark. Okay, first
Yeah.
p and then post. Okay,
Hmm.
clear? And then click OK. Then go to the variable view. Sorry. This is the mean of, this is step one.
Hmm.
Calculate mean for each participant. Clear?
Hmm.
Okay. Now the second step, we have to calculate the grand mean. Okay, and we can do that from the analysis descriptive statistics. So let me show you. Go to analyze, then descriptive statistics and descriptive. Okay. Then a grand mean. Sorry. Just a minute.
Hmm.
This is we don't need mean of pre and post. We need mean of this mean, grand mean. So just send it here and click OK. Okay.
Hmm.
So we have grand mean. This is the mean value. Just remember this value or note down somewhere because in the next step we need this value. Okay.
Hmm.
This 5.35. Okay.
Hmm.
Now the next step, you can see I have written the steps and I have the diagram is also here. Okay. Now after this step 3, we have to calculate the adjustment factor. So again we have to go to that compute variable um, box. Okay. So let me cross this. Oh no, we need it. 5.35. Okay. So go to transform compute variable. Just clear everything. You can do it from the reset button. Now your target variable will be adjust. Okay. How we are going to make the adjustment? We have to take the grand mean, that is 5.35, I guess.
Huh.
5.35.
5.3500.
0 we don't need. We'll take
Huh.
only two decimal.
Three.
5.35 minus the mean. Okay. You can see I have written here 5.35 minus mean.
Hmm.
Okay. And then click OK. Then go to the variable view. This is the adjustment. So some have positive, some are negative because some score are more than mean, some are less than mean. That is the reason why. Okay.
Hmm.
Now then, um, okay. Now we have to step 4. We have to create adjusted values for each variable. For each variable, we have to create an adjusted value, and that we can do how we have to again go to transfer, compute, and variable plus adjustment. I'm showing you. Just go here. Just okay. Graph. Sorry. Transform, compute, clear everything here. Okay. Type pre1 p underscore 1. Now send it here plus adjustment. Okay. I have written here variable plus adjust. Clear?
Hmm.
Then click OK. You'll get first adjusted value of pre-test, and then again go to transform, compute, just change it, post, and here also just send the sorry post test. Okay, and click OK. So we'll have adjusted value of both pre and post. Okay. Now we'll use this adjusted values to calculate our error bar. Okay.
Could you tell me again, like, why do we need to adjust this?
Okay. Uh, these are the cases, right? 1 to 10.
Huh.
Now this is a repeated measure design, means we are using same individuals in both situation, pre and post, or maybe in both conditions. Okay.
Huh.
Now we but these individuals, they differ from each other, right?
Hmm.
We cannot say that they're exactly same,
Huh.
right? Even if we try to control these different individual differences, we can control the individual differences. Like if we think that the individual they differ from each other, if they have different intelligence level, that can create differences. Okay. So we can do we can take participant with similar we can administer intelligence test, and we can take participant with similar IQ, right? But
Hmm.
it is not like that we'll take participant who has exactly same IQ. Means if one participant had 135 IQ, it means that all participant will have 135 IQ. It's not possible. We can
Huh.
take a participant who have similar IQ. Maybe they have 34 or 136. Okay, IQ. Or we can use other controlling way to other method in our research, in our design, to control the individual difference. Okay. but it is not possible for us to control individual difference completely. So this is the way by we are using statistically, so that it become it remain within group design, not a between group design.
Okay.
Is it clear?
Yes.
So you can see this is the adjusted final adjusted score of two variables or two situation. And now when we will do error, we will draw error bar, or we will do the test, we'll use this one, not the original one. Okay, now if I draw error bar following this, you can see there are some changes in the error graph. uh, Summaries for variables will take. Okay, define. Now just send them this side to pre and post, and we need this too, and click OK. So this is the one. They are still overlapping, but it is much better than the, you know, you can see this is better than the previous one. As our sample size is small, so definitely we will not get good data. We all know that if the sample size is large, that it's better. But still, you can see there are some changes, right?
Yes.
It is this one is comparatively better than the previous one. You can see not so much overlapping. Is it clear?
Yes.
And obviously, we can say we have done the adjustment. So it is statistically we have controlled the individual differences. Clear?
Yes.
Sure. Okay. So the steps are clear now. So don't get confused, because once you have opened this slide, you can follow the steps. Okay. Clear?
Yes.
So finally, you have to draw the error graph that I have shown you following the steps. Okay. Oh, sorry. This is the between group design. You have to draw the error bar, and we can see the changes. Is it clear now?
Yes.
Okay. So what we have discussed, that what is research design, what is standard error, what is confidence interval, how to draw error bar for both dependent and independent group. Okay. Now
Mm.
we'll discuss t-test. Any question?
No, no questions.
Okay. Now we'll discuss t-test. Now, t-test, we all know that t-test, there are two type of t-test, independent and dependent, and we can use only t-test only when there are two groups. If there is more than two groups, we can use t-test, but that will be very difficult to handle. In that situation, we use ANOVA. Okay. So
Hmm.
ANOVA today will not discuss. We'll discuss the next class. So
Hmm.
today we'll discuss two type of t-test. First is independent mean t-test and dependent mean t-test. When we are using repeated measure design or within group design, we use dependent mean t-test, and when we are using independent group or between group, we use independent t-test. It is clear?
Yes.
Okay. Why we need t-test? I'm not going to read this slide. I'm just explaining you. We have a hypothesis when we are doing any experimental research. I have mentioned this thing. You can read, but I'm explaining you that why we need t-test, because when we are doing our experimental research, we have two hypotheses: null hypothesis and alternative hypothesis, right? So null hypothesis, I assume that the manipulation of IV does not have any effect on the participant, and alternative hypothesis assume that the manipulation of IV has effect on the participant. Okay, so to test these two hypotheses, if there are two group or two mean, we use t-test. The t-test will tell us whether the difference between two groups is because of the IV manipulation or because of the chance factor, means because of the unsystematic variation. Okay, if the difference is significant, then we can say that okay, IV has some effect on DV. But if the difference is not significant, then we'll say the difference is due to the chance factor, not because of IV. That is the rationale behind t-test. Is it clear?
Yes.
Already I've discussed this thing. Okay.
Hmm.
So what are the assumption? Both independent and dependent t-test, they are parametric test. Okay. Uh, for independent t-test, sorry, for dependent t-test, first we have to see for both independent and dependent, you have to check whether they are normally distributed. Already have discussed this assumption. Okay. And they are measured on interval level. At least one data is measured at interval level. Okay. And one more thing, it is not written here, but you have to remember, when we are using dependent t-test, the two measure or two variable, they are correlated. Okay, you can see when we are calculate t-test using SPSS, you will see there is a separate table for correlation. Okay, because these two, in case of dependent t-test,
Okay.
dependent t-test means we are calculating same group in two situation. So these two situation, they are related, so they have correlation.
Huh.
Okay, so assumptions are first, for both of them, they are taken from the same population, sorry, normally distributed population. Data are measured at least at interval level. Okay. For independent test, we will have the concept of homogeneity of variance. Okay. Now, can you tell me why we don't need this assumption in case of dependent t-test, homogeneity of variance?
Mm, no, no.
No, why?
No, I mean, like, I don't know the answer.
Oh, no, the
I
answer.
can figure out why.
Okay. Is it very confusing, dependent and independent? Are you confused?
I think I'll need a little more reading. Like, I'm getting the basic concept, but then there's
Okay.
a lot of overlapping.
Yes, yes, yes. You need to read, definitely. Look, uh, when we are using repeated measure design or dependent t-test, it means we are taking the same sample, right?
Hmm.
So they are similar. We know, it is assumed that they are similar, and this is the reason why we have done all this adjustment and correction and all things. So why we need this variation of homogeneity of variance assumption? Okay, because they are same. The same population I am using in different
Huh.
condition. Okay, so we don't need this assumption of homogeneity variance. Simply we need the assumption of normality. The population, they are normally
Okay.
distributed, and they are correlated. Okay, but
Oh,
when we are using, because here there's only one sample is there, we're using the same sample again and again. So we don't need to need the assumption that the sample, they are similar, or they are taken from same, they have similar variance. Okay,
hmm.
but in dependent test, we are using different sample. Okay,
Okay.
so we need the homogeneity of variance concept, because the population should have equal variance. Group A and group B, they are different and they should have equal variance. Otherwise, we cannot use t-test. Is it clear?
Yes.
Okay. So if the assumptions are not fulfilled, then how we are going to interpret the mean, that we will discuss in details in non-parametric section. So today I'm not discussing that. Non-parametric will discuss separately. There we'll discuss. Okay.
Okay.
So simply, when you want to, like, the rule is that when you want to do analysis, first you have to go through all the bars and everything, sorry, all the graphs and everything, and then you have to check the assumption of normality and homogeneity, and then you have to decide whether you are going to use t-test or whether you are going to non-parametric statistics. Okay, so but in today's class this is about t-test, so I will only focus on t-test. Okay,
Okay.
so but it is required that you check the assumption first.
Hmm.
Okay, so what I was thinking, that the last class, we will do, if it necessary, then I will take maybe 1 or half an hour extra. Okay,
Hmm.
then we'll do, no, we will summarize the thing. Means we'll take our data separately, and we'll check how we are going to use analyze the data. Then you will have a complete picture.
Okay.
I think. Okay.
Hmm.
Okay. So, so you have checked your assumption. So what you have to do, like, you have a data, you know it is repeated measure or it is independent data. So suppose it is a pre-post test, means it is a repeated measure data. So you have to check assumption whether they are normally distributed, whether the variables are correlated, like this. Okay.
Hmm.
Then you can do the, then we'll you can do the statistics. Now first I will discuss dependent t-test. Okay. So I've given some example. Like I say, suppose I want to know the memory test score of elderly individual in the morning session, and in the morning and in the afternoon. So to see the effect of time of the day on their memory. Okay. So here I'm using the same sample in two situations. So that is a repeated measure design. Clear?
Hmm.
Okay, so what we have to do, this is the formula. Obviously, we don't have to use the formula to in SPSS, but this is a formula. If you calculate manually, you have to use this formula. I have explained the formula here, so I'm not explaining it in details. Okay.
Okay.
Then how to calculate the dependent t-test. These are the steps. First, analyze, compare mean, and pair sample t-test. So just let me show you. This is our score. This is for dependent t-test. So I will go to analyze, compare mean. Here you can see, you can find ANOVA and t-test, everything here. This pair sample t-test. Okay. So just send the pair here. And in option, you can see it is already set 95% confident interval. So you don't have to do anything here. Just click continue. And okay. Okay. So these are the tables. Now I will explain you the tables one by one. The steps are clear now?
Yes.
Okay. Now, so the first table is pair sample statistics. Here we can see the mean and standard deviation, standard error, everything. Okay. We need mean and mean to explain the differences and everything. Clear?
Hmm.
Then next table is pair sample test. Let me show you here. Okay, this is showing the table show the values, degree of freedom, and one tail or two tail. Okay, just let me show you here. This table. Okay, there is a correlation table. I forgot to mention here the correlation table, or I missed the slide. Yeah, that is the peer sample. I missed the slide. Peer sample correlation. It indicate the correlation value. Like I said, that these two things they should be correlated. Okay, you can
Hmm.
see it is significant. Okay, if it is one tail or two tail, you can see, you can check both of them are significant. Okay, clear correlation.
Hmm.
Okay, then we have pair sample test. This is a table where we can interpret the value of t. This is a mean standard deviation again. Okay, mean and standard deviation of this pre and post. Okay, and this is the value of t. DF, you know, degrees of freedom, and you have to check this one, one tail or two tail, the significant level. Both of them are non-significant, so we don't need any. We can say that they are not significant. You know how to check significant level? Zero
Uh,
point zero 0.05, 0.01 level less than 0.05, and 0.01 level means significant.
okay.
Okay,
Okay.
that one you know, na, that thing we do in manually, the same thing.
Yeah, but then it's just like I have each time I have to check, I do refer my notes.
It's confusing, I know, but it's just remember, it is the value of significant value is less than 0.01 or 0.05, then it is not significant. Okay, so here it is obviously more than 0.05. Sorry, I said if the value is less than 0.01 or 0.05, then it is significant. So here both of them are more than 0.05, so they are not significant. Different is not significant. And we also see in the error we also see in the bar error sorry, in the error bar, that they are not significant because they are overlapping,
Huh.
right? Okay, so your graph will again support your data, right? And even after correction, still they are not significant. Just one thing, remember, here we have taken only 10 samples. 10 sample, for 10 sample it is difficult to, you know, find differences. But if when we are doing actual research and we are using a large sample, then we can see that after correction, lot of differences are there. Okay, now if like if you make any prediction about the direction, means if then you have to use two tail test. And if you don't want to make any prediction about the direction, then group differences, then one tail test. Means group A and group B, they different. If you want to check whether group A is significantly significantly better or significantly larger than group B, in that case you will use one tail test. But if you just want to know if the group differs significantly from each other, then we'll use two-tailed test. Okay. But here in SPSS, you can see that depends on your research question. Okay.
Okay.
But here we have the score for a significant score for both of them. So it's up to you whether it is up to your research question that what you want to know. Clear?
Hmm.
Okay. Now, significant difference is not everything. Even if there is significant difference, we have to know what is the effect size. Okay. So what is effect size then? Okay. Confident interval, I have explained this thing, so I'm not
Hmm.
explaining this slide again. Effect size means the way to quantify the difference between group. Means p value they tell us, p value means the t value or the significant sorry, p value means the significant value. Okay.
Hmm.
Significant value will tell us, okay, these two groups they differ significantly. But what is the how large is the difference or what is the effect of the difference? That we'll know from the effect size. This table. You can see. Okay.
Hmm.
Just let me show you here. This is the table. From here we can say that how effective is the difference or how large the difference is. Even if it is significant, still we need effect size to explain our data. Okay, so better if we use this thing, it will be better. Statistical interpretation will be better. And one more thing before explaining the effect size, I just want to show you. You can see here the confidence interval level, lower and upper. Like I was telling you, this is a range and between which our mean lies, population mean lies.
Hmm.
You can see here is so this is the level of confidence interval between this minus 4.80 and plus 1.4. The population mean is there within this range. Okay. Now it is clear now what is confidence interval.
Hmm.
That is a range.
Yes.
Okay. Now effect size, you can see two scores are there, Cohen D and Hedges G. It is
Correction.
correction. Okay,
Correction.
you can see this is written here. This standardizer. This is the effect size. Okay, and we use. Okay, I have mentioned here in the slide. These are the these are the table. Means if your D is Cohen D is 0.2, then it is small effect. It is 0.5, it is medium, and it is 0.8 or larger than large effect. Okay, and if your sample size is very small, then we have to do a correction. Means we don't have to do the correction manually. SPSS will do that for us. Just we have to use it. That is Hedges G correction. Okay, so
Hmm.
if my sample size is less than 20, then I will consider this one, this table. Okay, and as it is less than 0. Sorry, it is less. Uh, okay, so 4.53. Okay, so fx size 4.53 means if we okay, this is more than 0.04. If we multiply with uh, sorry with 100, it is less than 0.05. So the effect size is less than medium. It is smaller. It is between smaller and medium. Okay, sorry, it is smaller, not medium. Clear?
Hmm.
Okay, so if your sample size is less than 20, you have to use this correction.
Okay.
Okay, so this is the paired t-test. Now you can use another data to understand this thing. So what we have to do, just let us repeat this from the beginning. Okay. We'll do independent t-test. So code data. This one we cannot use. Okay, just use this one. We don't need coding variable here, so I'm deleting this column. These are the data. This is the n is 50. Okay. Now first we have to do the correction part, right?
Hmm.
So go to transform, compute mean, then mean on. You have to change the variables, but I'm not doing it just because I'm showing you the steps. Okay. Oh, just a minute. Okay. We have mean. Now we need to calculate grand mean. So go to analyze, uh, descriptive statistics, descriptive, then mean. So the grand mean is 121.33.
Hmm.
And again go to transform, compute. Here we have to adjust. Target variable is adjust. And grand mean is 121.33. Okay. So 121 is point 33 minus mean.
Me.
Okay. Click OK. This is the adjustment. Now we have to again calculate mean for the separate variable. From compute, reset. I'm just minimum A, target variable A. Sorry, P1 plus just okay. And again go to transform, compute E V2 plus adjust and click OK. So we have two corrected uh, variables. Okay. So now what we'll do next step, we'll draw the graph. How?
Graph.
There is a dialog
Yes.
and
Error. Go
error
to
bar.
the error bar now. Hmm.
Yeah, simple error bar. And which one will click here? This is between within group, so we'll click
Separate variables.
separate variables and define. We have to send A and B here. Okay. Then click OK. We have okay. You can see they're not at all overlapping.
Hmm.
Okay. Now we can assume that or we can predict that we'll get significant difference maybe. Okay. Now we have to do the t-test. So we'll go to analyze, uh, compare mean, pair sample t-test.
Just a minute. I'm just writing it down.
Okay.
Yeah.
So we don't. need to do anything here. If you have missing value, then you have to use this thing. Okay. Otherwise, we don't have any missing value, so we don't have to anything. And if you don't want to see the effect size, then you can deactivate it. Okay.
Okay.
But it's better you activate everything. Even if you don't want to interpret it, it's okay, it's fine. But when you are doing analysis, you should activate
Have
it.
it.
Okay. And you can use effect size to explain your data. So now we have you can see this is the significant level. This uh, is 0.01 level. This is less than 0.01. It is written less than 0.01. You can see.
Hmm.
Okay, so that is the reason why it is significant. Already we can predict this significant. Okay, now the sample size is more than 20, so we'll use Cohen D, and this has large effect size, more than 0.05. So it is large effect size. Okay, so we can simply this is simple, right? Is it any question you have from dependent t-test?
No, no questions.
Okay, just one thing I want to know. You have SPSS in our system?
No, but like I was planning to like download that 1 month trial so that I can practice all this.
Yeah, you can do that, but remember one thing: you only use a trial version for only once in a year. Means once you have downloaded it, after 12 within 12 months you cannot use it. Okay,
Okay.
so if you need for data analysis, then you cannot use it once it is over. So okay, so
Okay.
this they are highly significant, and we can predict that from the bar diagram. So you just need to know the concept of standard error confidence interval, but the calculation is very easy in these spaces.
Hmm.
And I somehow enjoy it a lot. I just take data and I like to analyze it in spaces. It's really very interesting, I think.
Okay.
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 So okay. So this is the way we do. We calculate independent t-test and we interpret the result. Okay.
Hmm.
Now we'll discuss how to calculate dependent t-test. Now we'll discuss independent t-test. Okay. So
Okay.
like I said, in independent t-test, you have to enter your data differently.
Hmm.
Okay. So let me show you. Oh, okay. So let me import the data. Any data to take. Okay, one more thing, I didn't do it, but whenever you are calculating t-test, you have to check the assumption. Okay,
Okay.
means if the assumption and are violated, you cannot use. Sorry, you cannot use t-test. Okay, so in the
Okay.
last in case of dependent t-test, I didn't check it, but you have to. Means we always have to check. Like I'm showing you the step. That's why I didn't check it, because even if the it is not a fulfilled now, I will use t-test to show you. But in when we are doing analysis, generally we are doing the analysis, we have to check the assumption. And many times, it is very surprising, but even if you have large sample, it is not fulfilling the assumption. I faced this problem a lot during my PhD thesis analysis and data analysis, and I have to use non-parametric statistics. I cannot use parametric even if my sample size was large. Okay, so
Okay.
obviously you have to check the assumption. Okay, now this is a between group in between group design. We have to enter data like this, and we have to add the value level. So 0 is pass and 1 is fail. So go to variable view. This is your variable, maybe A, and this is the group
Hmm.
values. 0 is male and 1 is female. And now Okay, so I have entered the data. Now we have to calculate it. Go to analyze, compare mean, and here is this option independent sample. Sorry, independent sample t-test. This one.
Hmm.
Grouping variable. In grouping variable, you have to send the group. Then you have to define the group. Your group is 0 and 1. Okay. And if you want to send any cut point, then you can mention here. Means you don't want to if you don't want to specify your group, just you want to set a cut point like score below this or score below 50 and score above 50, then you can also do that. But I prefer this one. It is easier for me. Okay.
Hmm.
Then continue, and this option called option, if you have, you can see here the confidence interval is 95% by default, so we don't need to change it. And if we have any missing value, then we can use this one.
Hmm.
Now click OK. So this is the table, you can see. Okay, now how to interpret this thing. Okay, you can see that in independent t-test we have this 11 test within it. We don't have to calculate it separately, we have 11 test within it. 11 test means the test of homogeneity
Hmm.
variances. Okay, and 11 test, this is a significant level. Okay, so the one which is significant, this row you have to use. You can see there are two things: equal variance assume, equal variance is not assumed. Okay, I have mentioned here in the PPT. You can see. This is a group statistics. I'm not explaining it. A simple mean standard deviations are there. Okay, in independent sample t-test, here you can see that there's a 11 test which is showing the homogeneity of variances. Okay, so we don't have to calculate it separately. We can easily check the assumption here. Now, if your significant value is greater than 0.5 in 11 tests, if it is greater than 0.5, it means they are homogeneous. We already know that. Okay,
Hmm.
so, if I have mentioned here, if the significant value is greater than 0.5, then we'll use the upper this row. And if it is less than 0.5, then we'll use this row for interpretation. Okay. So in this case, it is more than 0.5, 0.05 is significant level. So we'll use this row. More than 0.05 means the variances are equal. Homogeneity of variance. So we'll use this one. Okay. And if it is less than 0.05, then it means the homogeneity are not equal. So then we'll use this row. Is it clear?
Hmm.
Okay. Now, uh, this is the t value of t df, and these are the value of significant p value we say. Okay, and we can one tail test and two tail test, and we can see in both cases the p values are not significant. They're more than 0.05 or 0.01, so they are not significant. Okay,
Hmm.
and you can see also confidence interval values are here, the range within which we know the population mean may lie. Okay,
Hmm.
and these are the effect size. Effect size already I've explained. Here you can see glass
Hmm.
delta. Okay, now what is this? Okay, if the both group they have similar ST or same size. Okay, or many times what happen in between group design, we don't have same size. Maybe in one group there are 50 subjects, another group there are 54 subjects or 55 participants. Okay, so they are not equal size. In that case, we will use glass S delta correction. Okay, we will consider. We don't have to calculate anything. SPSS will do that for us. Just we have to consider it. Okay, and
Hmm.
if it is they have similar ST and same size of data, then we'll use Cohen D. And if the sample size is less than 20, we'll consider HS correction. And if it is more than 20, then we'll use Cohen D. Okay,
Okay.
and the range is same, like for all three all three effect size, the range is same. the like below 0.02 to 0.04 is the minimum effect, and more than 0.05 is 0.5 is the medium, and
Mm.
zero point 0.8 is larger effect. Okay, is it clear? The range is same. This range you have to use this one for all the three effect size.
Okay.
Yeah. Okay. But you have to consider, you have to check whether they have similar sample size or not. If the sample size is same, then you can use Cohendy. If it is not, then this glass delta. And if the sample size is large, then you have to use Cohendy. And if it is small, then you have to use Hedges correction. Okay.
Okay.
So this is not very difficult. This is easy, no? Steps, this independent and dependent t-test. Okay. So let me use another data. Okay. Fine. Put it down. So this is we have 138. Okay, means yeah. So out of 138, till 72, we have zero. Okay. So the group size is not equal here. You can see. So let me calculate the frequency first. Frequencies too. Okay. So we have, oh, now equal sample size we have. Okay.
Mm.
I always forget one thing. Please do remember it whenever we are doing the frequency table. Uh, there is an option called create table using APA style.
Huh.
Better you click this one, okay? Because whenever you are reporting your data, you need to use table following APA style. So you have to. It is better we click that option, okay? So we have. Now, we don't need to do any kind of correction here because this is between group design. We'll simply calculate the error bar. Simple. Which one we have to click here?
Separate variables.
No, separate variables for dependent or between group design.
Okay.
Within group design. In between group design, we have to summaries for the group of cases.
Okay.
Well, spaces will give you definitely give you a bar, but that will be that is means there will be error. Okay, so here
Mm.
you can see variable. There's an option we sent variable there, and group in the categorical category axis. Confident interval is 95. Then click OK. We'll get our
Mm.
okay. So
Mm.
they are not overlapping. Okay, so we can predict that there will be significant difference. Okay,
Different.
one more thing before doing this thing, we have to obviously check the assumption, and we can draw a blocks plot. Obviously you have to do that. Okay,
Hmm.
just let me do it to confirm that there is no outlier, and if there is outlier, then we have to do the necessary correction. Okay, simple blocks plot, summaries for the group of cases. Mhm. Variable categorical access. So there is no box.
No.
Data is it is a good one, more or less, right?
Hmm.
But you have to do it, and you can justify your calculation. You can justify your interpretation for using this graphs. Okay. Now we'll do the independent t-test. Simply go to analyze, compare independent sample t-test. Test variable is A, and grouping variable is the group. Then you have to define. You can use one and two also, but I use one for my, so that I don't get confused,
Hmm.
because already I have set na. So this is the data we have. Sorry. So this is the group statistic. This is the 11 test. So this is not significant. It means equal variance are there. So check this one. Then we can see it is significant, right?
Hmm.
Less than, it is highly significant. Okay. And here we have to check the effect size. Uh, it is so equal size, so we will use, and large sample is 20. Okay, one thing remember, many times we get really, like, we always want to have, like, we always want that our data is high, is highly significant. Okay, but it may happen that your data, they are not is highly significant, but
Hmm.
it doesn't mean that it is your fault or there is something wrong, you cannot explain your findings. Okay, so it's not like that. We have to think, okay, we need highly significant data. Many times it may happen that if your data, all the data, all the analysis are highly significant, then there is a chance that we think, okay, maybe we have done some kind of manipulation or something. It's not like that. It can be, it can happen that all the mean differences are highly significant, but if it is not, then it doesn't mean that there is something wrong in my data. Anything can happen. You have to interpret your data. Maybe your data is not significant, highly significant, but from the graph you can see there are some differences, right? So
Huh.
you can say that, okay, maybe my data is not significant, there is no significant difference, but uh, from the graph I can say there are some changes in the pre and post test, and maybe I need to give intervention for more duration. So you can interpret, you have to justify your answer, you have to justify your interpretation. Okay, and
Hmm.
you can use graph there. Okay, so it is not like, many time when we are doing analysis, always we want, okay, our data, there should be high, they should be highly significant, there should be significant difference between the mean, but it is not like that. Many times it can happen.
Yeah,
Okay.
even in my
Mhm.
dissertation, like it was correlation between resilience and psychological well-being, and
Mhm.
like throughout the process, I was very confident that it'll be like a significant positive correlation. But like the sample I got, it was came out as negative and low like significant correlation. I got so scared. I was
No,
like,
no,
I
in
thought
that
that it
situation.
will get rejected or something.
No, 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 no. You, in that situation, what you have to do, when we have an assumption, okay, these two variables, they should be highly correlated, okay, or
Yeah.
significantly correlated. But when it is not, then it is a new finding, and then you have to go through the literature. You have to see that why or what may be the reason. No, in research, we want to find something. We want to find the
Mm,
reason behind something. So if it is like that, okay, I know they are significant and there is a significant difference, and there's nothing new now. So I know many interesting thing can happen when we are analyzing data, and we have to be open to accept and interpret everything. And we can use our observation, we can use our graph to explain the data. In my situation, my what I did, it was qualitative, quantitative entirely, but what I did when I was collecting data, na, I wrote down my observation, day to day observation. I had a record of the day to day observation, and then I used that qualitative observation to explain my data. Okay, maybe there is not statistically significant difference, but some trends are there, some changes are there, and I can see that in my graph also. Okay,
mm,
so be open to accept anything. It's not like that your data is wrong.
mm,
Only if you manipulate your data, you just simply write your data without collecting, and that is wrong. Otherwise, data is not, it is never wrong. Whatever you are getting, you have to explain, you have to justify your answer. That is my understanding. I feel that. Okay.
mm.
Hope it is clear now today, the test.
Yes, it is.
Okay. So just a minute.